In this segment, we are going to look at a type of combinational circuit called array multiplier. So the combinational circuits we looked at so far included adders and subtractors, which, as the name suggests, were used for performing addition and subtraction operations respectively. So array multiplier is one of the combinational circuits used to perform a multiplication operation. So we are going to take the example of a 2-digit into 2-digit multiplication and understand how the array multiplier works. So before we go into the array multiplier, let us first take this numerical example of 23 multiplied by 31, and we shall perform normal arithmetic multiplication, and then we will extend the same idea of the procedure to the multiplier and we'll look at the circuit diagram. So when we have a 2-digit into 2-digit multiplication, this is the first number is called the multiplicand, and generally the second number is called the multiplier. So we take the last digit of the multiplier, we multiply it with each digit of the multiplicand and write down the corresponding partial product. So 1 times 3 is 3, 1 times 2 is 2. Then we move on to the next digit, we shift 1 bit left over here, 3 times 3 is 9, 3 times 2 are 6. So each of these digits here is called a partial product, because it is not the entire answer, it represents a part of the final product, and each of these digits there is obtained by multiplying 2 digits, so we call them a partial product. Now how do we get the final result from these partial products? We have to compute the sum. 3 plus 0 is 3, 9 plus 2 is 11, we get a carry here, 6 plus 1 is 7. So this is how normal multiplication works, right? Now we will look at the same thing using variables a and b instead of actual numbers. So let's assume we have 2-digit numbers. A1, A0 represents the number a, where A1 and A0 are the tens and units digits respectively. B1 and B0 are the tens and units digits of your multiplier, the second number b. So what will our partial products look like? A0, B0, A1, B0, here we leave a space, A0, B1, A1, B1 over here. This is what the conventional multiplication encompasses, right? So this is how your partial products are formed once you have done the first step of a normal 2 cross 2 multiplication. Now to sum up the partial products, what do? This is just A0, B0 and it's a 0 here. So the last digit of your final product will generally just be A0, B0. The second last digit will be A1, B0 plus A0, B1. And the third digit will be A1, B1 plus a carry generated from this addition, if any. If there is no carry, this bit becomes 0 and your answer is just A1, B1. If there is a carry, you add that with this partial product to get your answer. And in a 2-digit cross 2-digit multiplication, generally your result will be at most 3 digits. So this is the general way of multiplication. Now this is what we are going to depict using a circuit. So our inputs are 4 lines, A0, B0, A1 and B1, the digits, and let us remember that the same rule applies for binary multiplication as well. So if you have a number, a multiplication 1, 0 cross 0, 1, that's exactly how it would work. You add 0, 1, 0. This is how the multiplication would work. So by the same logic, we are now going to implement this as a circuit. So our inputs are A0, B0, A1 and B1. Each of these is a binary value. It can be a 0 or a 1. So A0, A1 is a number, B0, B1 is a number in binary. So if let's say according to this example, if A0 is 0 and A1 is 1, then my number is 1, 0, which is the binary representation of 2. Similarly, if B1 is a 0 and B0 is a 1, then my second number is going to be 0, 1, which is the binary representation of 1, and so on. So these are our 4 inputs. So let us first compute the partial products using AND gate. So we have A0, B0, A1, B0, A0, B1 and A1, B1, which are the 4 partial products we computed here. How is each partial product computed? By connecting the two respective digits to an AND gate. Now, as we notice here, A0, B0 directly goes into the output. It becomes the last digit of the output. So that's what you can see here. A0, B0 directly becomes the last digit of the output. The second digit is the sum of A1, B0 and A0, B1. So you have two inputs and you need to compute the sum. That becomes the second digit of the output. So we take these two inputs, we put them through a half adder, which is a combinational circuit you are already familiar with, and the sum becomes the second last digit of your output. Meanwhile, the carry along with the one remaining partial product, their sum becomes the last, or rather the first digit of your final product. So we take the remaining partial product and we take the carry from this previous half adder, we add both of that, and the sum and carry, both of them become part of your output. So this is what an array multiplier circuit looks like. So what is this circuit doing? It is performing multiplication of 2-digit number times a 2-digit number. And what is the logic? There is no special algorithm or computerized logic here. It is the same normal multiplication logic which we use while performing a pen and paper calculation. So we have 4 inputs. We calculate the 4 partial products, which are the products of 2 digits, one from the multiplicand and one from the multiplier. There are 4 such combinations, so we get 4 partial products. The last one, A0, B0, directly goes to the output. The middle two, they are added using a half adder. The sum becomes a part of the output. The carry goes to another half adder along with the A1, B1 partial product. This partial product and this carry are added together, and the sum and carry from this half adder also become part of the output, which is exactly how a normal multiplication works. So that is array multiplier.